All right, section 5.3. We're going to start with this triangle right here. This should look fairly familiar to you. Let's call this angle 1 right here. Let's call this angle 2 up top. Let's call this angle 3. Now, we learned something, I don't know, a lesson or two ago. I forget exactly what lesson it was. But we learned a relationship between this angle. Now, look, this angle's on the outside of the triangle. So what do we call this angle? What's the name of it? It's an exterior angle, right? It's on the outside, right? Outside is exterior. Kids normally don't say exterior. You know, if you're talking, you usually say it's outside. But you listen to older people, they like to use bigger words or whatever, and they'll say exterior. But we all know that. Thank you. So that's the exterior angle. Look at these two angles right here, 2 and 3. We had a specific name for those types of angles. They're further away. They're not the one that's right next to it. They're two that are further away. What word did we use for that? We went through this big story about sitting in front of a TV, a remote. Remote what? Interior angles. Okay, these are the remote interior angles, and this is the exterior angle. Remember that? Well, what did we learn back then? We learned that angle 1 was equal to what?
Angle 2 plus 3.
Plus 3. That's right. Angle 2 plus 3. At least Scrappy was listening. Doesn't sound like anybody else was. All right, but there we go. Angle 1, this exterior angle, is equal to angle 2 plus angle 3. Remember, the exterior angle is equal to the sum of the remote interior angles. We good with that? All right, what I want to talk about right now is I want to talk about what angle is bigger and which one's smaller. Okay, that's what we're going to talk about today. We're talking about inequalities. One's bigger, one's smaller. So watch, if angle 1 is equal to angle 2 plus 3, if 2 and 3 have to add up to be equal to angle 1, tell me something about angle 1 compared to angle 2. It's got to be bigger. Would you agree? If I took two things and added them together, right, and got an answer, that answer has to, now, when I say add them together, I'm talking about positive numbers, not talking about negative numbers. There's a difference, okay? Talking about positive numbers. If I had a number, or if I had two things and I added them together and it equals the answer, that answer has to be bigger than either one of those two things that are being added together. Would you agree? Right? So if I gave Kenny $5 and then I gave him $3, he's got what? $8. He's going to have more than that 5 and he's going to have more than that 3. Would you agree? Because the two have to add together to become that 8. So angle 1 has to be greater than angle 2. Do you remember the symbol for greater than? Yeah, like that. Okay? I made it extra big just because sometimes those angle symbols kind of blend in and kind of look like this greater than or equal stuff if you don't draw them just right. I made it a little extra big. So angle 1 has to be greater than angle 2. Does that make sense? Well, angle 1 has to also be greater than what else? Angle 3. That's right. So just by looking at this picture right here, I didn't tell you anything about the measurements of these angles, did I? I didn't say that angle 2 was 30 degrees or angle 3 was 40 degrees or anything like that. Okay, all I showed you was this picture. We extended the side. This is the exterior angle. We know that the exterior angle is equal to the sum of the remote interior angles, which means these two further away from this one have to add up to be 1. Well, if they add up to be 1, one's got to be bigger than 2, and one's got to be bigger than 3. Would you agree with that? Yep. Not just by looking at it, not just by saying, well, it kind of looks bigger. No, you don't just look at the picture and say, well, it kind of looks bigger than this and it looks bigger than this. No, we go by this information right here. Because sometimes, are you listening? Christian, you with us here? All right, head up, please. Sometimes you're going to see a picture and it may not look, and you may not be able to tell, or they may not draw it to scale. And you may not be able to look at that angle and say, wow, it looks like that angle's bigger than that angle. You can't just go by that, all right? You can't just go by what it looks like because you can't always be sure about it. You can be sure about this. If this is an exterior angle, it has to be bigger than either this one or this one. Agreed? Does that mean it has to be bigger than this one right here? No. Doesn't say anything about if this is bigger than this or not. All right? It can only be, you can only tell that it's bigger than 2 and 3. And you're going to have some problems on the worksheet. They're going to ask you that. Okay? Which is the bigger angle? Or it'll say something about, how does it say it? Let me see. don't see one in here that... Oh, it'll say something about what is the relationship between these angles. If it says what's the relationship, what it's asking for is this. It's saying which one is bigger than the other one. Okay, so when it says what's the relationship, either they're equal to each other, or one angle is bigger than another, or one angle is smaller than another. So right now we can just say angle 1 is greater than angle 2, and angle 1 is also greater than angle 3. Got it? Okay, I think we've covered that enough. Let's move on to something else. All right, here's another triangle. We're going to do something a little bit different with this, where we're still going to talk about which one's bigger, which one's smaller. That's this whole thing. It's called inequalities. This whole lesson's about inequalities in one triangle. Which side is bigger, which side is smaller, which angle is bigger, which angle is smaller. Okay, that kind of stuff. So, look at this situation I've got right here. Let's say that, we'll call this ABC. Now this definitely looks obtuse, doesn't it? Okay, so an obtuse angle, in a triangle, the obtuse angle has to be the biggest angle. Would you agree with that? All right, because you can't have any more than one obtuse angle, right? So it has to be the biggest angle, all right, that obtuse angle. So if this is the biggest angle, this is what our theorem says. If you have one triangle and you know which one's the biggest angle, the side opposite that biggest angle is going to be the biggest side. Everybody see that? So if this is the biggest angle, angle B is the biggest, which side is the biggest side? AC. AC. This is the only thing that I know, okay? This is the only thing we'll say it's given, all right? It's given that angle B is, that doesn't look like a B, does it? Let's try that again. Angle B is the largest angle. Okay, so angle B is the largest angle. They tell you that, all right? We okay with that? It's not like we just had to look at it. They told you angle B was the largest angle. But what you can figure out the largest side. So if I told you the largest angle was angle B, then the largest side would be side AC. So if I said, what is the largest side? What is the largest side? And the largest side, question mark, what is the largest side? You would say line segment AC. And how do you know that? Because the largest side is always opposite, guess what? The largest angle, okay? What do you think the converse of that would be? Right, what if I told you AC was the largest side? Then you could say that angle B is the largest angle. Works both ways. Then BC would be the largest side, that's right. Okay, so if, okay, it's a big if because that's way smaller than this, okay, just by looking at it. But if they told you that angle A was the largest angle, then which one would be the largest side? BC. What if, again, this is a big what if. What if angle C was the largest? Then AB would be the largest side. You get it? Okay. Or you could say, what if AB was the smallest? Let's go in that order. I'll tell you what, C looks a little smaller, doesn't it? So watch, let's say angle C was the smallest side. What do you think you could say? I'm sorry, angle C is the smallest angle, not the smallest side. Then AB would be the what? The smallest side, because it's opposite the smallest angle. You with me on that? So whatever side is opposite the biggest angle, that's going to be the biggest side. Whatever side is opposite the smallest angle, it's going to be the smallest side. And of course the other one would be the one that's in between. Does it make sense? Okay. So, just for fun, let's make up some angles here. What do you think that is? That's probably about, oh, it's probably way bigger than 110. It's probably more like 150. Okay? And then let's say this is, let's say that's 10 degrees. Then what would this one, if that's 150 and that's 10, what would this be right there?
20.
It'd be 20. Right, because that's 160, right? There's 180 altogether, so 180 minus 160 is 20. Everybody with me? Scrap, you paying attention? Okay, good. Let's see. Now, what if I wanted to put the sides, write the sides, in order from, let's say, smallest to largest? From small to large, okay, the sides. And this was what was given. You sure?
No, it's just small.
Sides, not angles. Not angles, the sides. AB would be the smallest one because it's opposite the smallest angle. Do you see that? What would the next one be? BC would be the next one because it's opposite the middle angle, right? Because we go 10, 20, then 150. And then what's the largest one? AC would be the largest because it's opposite the largest angle. Pretty easy stuff, isn't it? Would you agree? Yep. All right, let's change this around a little bit. Let's get rid of these. And let's get rid of these. Again, I'm just making this up. Let's say this is 20. Let's say this is, I don't know, 10. Let's say that's 15. All right, just for fun, we'll say that. Now, what if I asked you about the angles from small to large? Okay, so the angles this time from smallest to largest. So the smallest, you look for the smallest side first, don't you? Smallest side is this one. What's opposite? What angle is opposite this side? Angle C. And then, well, angle C. And then what's the next one? 15, right? So what's opposite? What angle is opposite this side BC? Angle A. And then, of course, the largest one, this is 20. That's the largest side. So what's the largest angle? Angle B. Process of elimination anyway, right? What do you think? Pretty easy stuff, isn't it? All right, so if they tell you the smallest side, you should be able to tell the smallest angle. If they tell you the largest side, you should be able to tell the largest angle, and vice versa. All right. You know what? I don't think there's much more to this.
All right, we're done. Sweet.
Let's do one more just for fun here. Okay. And what if I tell you that's a right angle? And what if I tell you that that's 51 degrees? And again, we'll call it ABC, just because I'm not creative enough to come up with anything else. All right. And if I asked you the lengths of the sides from small to large again?
Is that 5, 10?
51 degrees. How could it be 510? One angle is 510 degrees. All right, and you need to list the angles from the smallest to the largest. So let's take a look. What do you think? What do you got to do first?
Sides, you gotta find the opposite of that.
Well, let's find this angle first. Figure out what that is, okay? So if this is 51, how do we figure out what this is? Yeah, well, let's go 90 minus 51, right? Which would be what? 90 minus 51 would be 39. How about 39? Right? Because 5 and 3 is 8, but that's a 10. You got to carry the 1 to get it to be a 9, right? Yeah, so it's 39 degrees. Okay, so let's see what we can do. What's the smallest side? Well, you look for what? The smallest angle. Smallest angle is 39. So which one's the smallest side? AB. So AB would be the smallest side. Which would be the next one in order? You look at the 51, right? That comes next. All right, so opposite the 51 is BC. It is. Except you just had to figure this angle out. And then this is 90, so 90, opposite that is AC. Now, we haven't really talked about this. We're going to have a whole chapter where we talk just about right triangles. Are we listening, Kenny? I'm up here. We're going to have a whole chapter where we talk about right triangles. But what do we call AC? Right, we call it the hypotenuse. Do you remember that? Hypotenuse is always opposite the right angle, and the hypotenuse, what else did you learn when you were a kid about hypotenuse? It's always the what?
Longest side.
It's always the longest side, right? Didn't you learn? You're right. We did learn Pythagorean theorem. She's absolutely right. We learned Pythagorean theorem. Okay, but what do we know about the hypotenuse? You're always told when you're a kid the hypotenuse is always the what? The longest side. Now you know why the hypotenuse is always the longest side. Because look, if I have a right triangle, that 90-degree angle is always going to be the biggest angle, isn't it? So the side opposite the largest angle, I can go over 15 now. Thanks. Anyway, I can go like unlimited now
Wait, why?
Why?
because I'm special.
Oh.
I don't know. I don't know. A couple weeks ago, they had a thing come up on there and said you are now eligible to go longer than 15 minutes. So we tested it out in my other class. Well, it said something like that. I said something like it. I didn't say exactly. Anyway, watch. My point is this. On a right triangle, the right angle is always the largest angle, isn't it? Okay. So opposite the right angle is the largest side. That's why the hypotenuse is always the largest side of a right
Bryant, please
triangle.
come to the upper school office. Breon Bryant.
Okay, we good with that? Oh, they fixed my speakers too.
It's not.
You just get no type of
I'm
present.
telling you, man, it's awesome. It's like Christmas all over again. All right, well that's good. Let's. I'll give you a worksheet, and then you can start working on this.